Hello everyone, I hope you're doing well today. Today we're going to learn how to solve a quadratic equation by inspection. When we solve by inspection, that means that we're using inverse operations or operations that undo each other. Looking at my first example, x squared equals 4. The inverse of a square is the square root. So I'm going to take the square root of both sides of my equation. The square root of 4 is 2. But the square root of 4 is also negative 2. So we say x is equal to plus or minus 2. The reason why that works out is if I take 2 and I square it, I get 4. But if I square negative 2, it's also 4, because 2 times 2 is 4, negative 2 times negative 2 is 4. So when we take the square root of a number, we always have to remember to take both the positive and negative root. Looking at my second example, the first inverse operation I would have to use is addition, because I need to try to isolate x. So I would add 3 to both sides of my equation to get x squared equals 16. Then to undo the square, I would take the square root of both sides of my equation and get x is equal to plus or minus 4. Finally, looking at the third example here, I have 2x squared equals 50. To isolate x, the first thing I would have to do is divide both sides of my equation by 2. So I'd have x squared is equal to 25. To undo the square, I would have to take the square root of both sides of my equation and get x is equal to plus or minus 5. Please take a moment to pause this video and record these examples in your notes. Next, I would like to look at the example 3x squared plus 4 equals 31. Now in here I have 3 operations to undo. I have to undo my multiplication, my exponent, and my addition. The first one that I always get rid of first is addition or subtraction. So I'm going to get rid of my addition by subtracting 4 from both sides and rewrite my equation as 3x squared equals 27. After getting rid of addition or subtraction, I would get rid of multiplication or division, so I divide both sides of my equation by 3 and get 3x squared, just x squared equals 9. To get rid of the square, or my exponent, I'd take the square root of both sides of my equation and get x equals plus or minus 3. Please take a moment to pause this video and record this example in your notes. Now our next example is a little bit more tricky. I have the quantity of x minus 5 squared equals 36. Well, since the subtraction is in parentheses, I can't get rid of that yet, so I have to get rid of my square root first. Get rid of my exponent first by taking the square root. So then I'd be left with x minus 5 equals, and the square root of 36 is plus or minus 6. To continue isolating my equation, I would add 5 to both sides of my equation, and I would get x equals 5 plus or minus 6. That means that I have to break this down into 2 separate parts. I need to first do x equals 5 plus 6 to get 11, but I also have to do x equals 5 minus 6 to get negative 1. Occasionally when we solve a quadratic equation, we will end up with more than one answer. For this particular example, we found out that x equals both 11 and negative 1. If we plug them in to check them, 11 minus 5 is 6, and 6 squared is 36. Negative 1 minus 5 is negative 6, negative 6 squared is 36, so both solutions work. When you solve a quadratic equation, sometimes your final step might be breaking it down into 2 separate equations to finish solving. Please take a moment to pause this video and record this example in your notes. I'd like to look at one more example together before you try some problems on your own. So we have the equation, the quantity of x plus 3 squared minus 1 equals 15. Well, I do have subtraction to get rid of, which is always the first thing to get rid of, addition or subtraction. So I'm going to get rid of my subtraction by adding 1 to both sides of my equation. So I'm left with x plus 3, the quantity of x plus 3 squared equals 16. Now I can't get rid of my addition of plus 3 yet because it's inside parentheses, so I have to get rid of my exponent first by taking the square root of both sides. So I'm left with x plus 3 equals plus or minus 4. Now I can get rid of my addition by subtracting 3 from both sides of my equation, and I get x equals negative 3 plus or minus 4. So now again I have to break this down into two separate equations. X equals negative 3 plus 4 and x equals negative 3 minus 4. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Therefore, my values for x are 1 and negative 7. We can check these both by plugging them in. 1 plus 3 is 4. 4 squared is 16. 16 minus 1 is 15. That checks out. If I plug in negative 7 plus 3 is negative 4. Negative 4 squared is 16, and 16 minus 1 is 15. Please take a moment to pause this video, record this example in your notes, as well as any questions that you may have. Take care, stay safe, and be well. I will see you soon in our next Zoom meeting.